Hello class, and welcome to Math Minutes video lesson number 33. We're going to start looking at how to solve for systems of equations. And there's more than one way to do this, but this lesson is going to focus on the first way we learn, and that is how to find the solution by graphing. So open up your notebooks to page 8 and we will get started. Solving systems of equations by graphing. A system of equations is a set of two linear equations that are solved together. There are three different ways to solve systems. The first way we will learn is by graphing. The solution to a system of equations is a coordinate. And what does that mean? Let's look at the example. We have two lines that have been graphed on this graph. These are the lines represented by these equations here. Let's look at the first line. If we were to graph this, y equals 1/2 x plus 2, we would start at the plus 2, that's right there. And we have a 1/2 slope, which is up 1 over 2, up 1 over 2. So this is our first line. The second line, we started by putting a point at 7. This is 7. And it has a slope of negative 1/3 x, which means down 1 to the right 3. Down 1 to the right 3. That's the second line. You see that they intersect at one point right here. So the solution is this coordinate where, where they intersect. This happens to be the point of 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So the solution is the coordinate 6, 5. So let's go ahead and do some practicing. Let's start with the line y equals 1/2 x minus 3. And let's do another line, y equals negative 2x plus 1. So we graph the first line. We start at negative 3, 1, 2, 3. Our slope is 1/2, which means up 1 over 2. Up 1 over 2. And here we have our first line. And let's graph the second line. This one is going to be plus 1. So that means we're going to start right here. And it has a negative 2 slope. So we're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and we end up with a line like that. Now, because I had some random numbers and the graph is small, it's a little hard to see where they intersect. But the coordinate, let's say, is this point right here. That's as close as we can get. And what is that coordinate? Well, from our origin, it's 2 to the right and 2 down, which means the solution would be 2, negative 2. Let's try another one. And what if I have a line that says y equals 3x minus 4. And then I have y equals x plus 1. I don't know where these are going to intersect, but our solution is where they're going to intersect at that one point. So let's see what this one does. We're starting at negative 4, so we'll go down 1, 2, 3, 4. Our slope is 3. Up 3 to the right 1. Up 3 to the right 1. There's our first line. Our second line starts at plus 1. And what is this slope? Well, there's not a number in front of it, but really there's a 1 in front of it. So this is a 1 slope, 1 over 1. That means we're going to go up 1 over 1, up 1 over 1, up 1 over 1. And we end up with a line that looks like that. Again, I'm sorry, fat markers and a small graph, but I hope you're getting the idea. Where do these lines cross? 1, 2, 3, 1, 2, 3, approximately 3, 4. Again, if you were to check these another way, these are a little bit off, but that's our best 3, 4 right there. Okay, let's do a little bit more practice. Okay, let's say y equals, let's go 2/3 x plus 1. And let's say y equals negative x minus 3. How do we graph the first one? We start with the plus 1, which is right there. Has a 2/3 slope, up 2, to the right 3, up 2, to the right 3. There's our first line. Second line starts at negative 3, 1, 2, 3, and it has a negative 1 slope. So that means down 1 to the right 1, down 1 to the right 1. And there's our second line. And our best little estimate with our fat markers is what's the coordinate of this point. We're going to the left 1, 2. We're going to the left 2, so that would be a negative 2. And we're going down 1, so that would be a negative 1. And let's do one more like this. Y equals, let's say, 3x plus 5. And y equals 1/3 x minus 2. So we start with plus 5, 1, 2, 3, 4, 5. We have a 3 slope, 1, 2, 3 over 1, 1, 2, 3 over 1. There's our first line. Our second line, we start at negative 2. That's down here. And we have a 1/3 slope. Up 1 over 3, up 1 over 3. 1, 2, 3. There's our second line. And it looks like they intersect right there. What's that coordinate? From our origin, we're going to the left, 1, 2, 3, and down 3. So this is a negative 3 solution. So again, the solution is the one little point where these lines intersect. Now there's a few that I want to just show you. We have some exceptions where maybe these lines don't intersect at all. What if I had a line that was y equals, hate the smears, 2x plus 4, and I had another equation that said y equals 2x plus 8. Well, let's graph this one. This one starts at 4. 1, 2, 3, 4. 1, 2, 3, 4. With a slope of 2. Up 2 over 1. Up 2 over 1. There's my first line. This one starts at 8. Well, if this was 4, 5, 6, 7, this one starts up here, and it also has a 2 slope. Up 2 over 1, up 2. And that line will look like that. These lines are called parallel. So there is no solution. These lines will never intersect. And what is the fact that we understand about that? Maybe we remember this from last semester. Parallel lines have the same slope. There is no solution. They will never intersect. Another one that's a little exception to what we've been learning is this infinite solution. Let's take a look at what infinite solutions means. Infinite solutions means the two lines happen to be the same line. They're not intersecting at one point, they're actually on top of each other. It's the same line. So you might have two equations that come up with a line that looks like that, and the second line also looks like that. infinite solutions when the two lines are actually the same. Okay, so we've looked at how to find solutions of systems of equation. A system of equations is two or more equations that are solved together. And the first way we did that was to graph. The solution is the one point, the one coordinate where they intersect. Okay, I hope that makes some sense. Of course, we'll be always practicing in class, and there's also extra help on your Math Excel if you still have questions on certain problems. Good luck, and I'll see you in class.